Hello everyone. In the previous video, we covered a lot of similarities between string sequences and list sequences. That would be these 7 operations which you can perform on any type of sequence. Let's talk about the differences. Last lecture, we covered various string methods like find, replace, upper, lower, and so on. All of those methods are specifically applicable only to string sequences. In today's lecture, we'll be covering methods that are specifically applicable only to list sequences. Unlike strings, lists are mutable. I'll be defining the term mutability in a couple of slides. Lists provide flexibility in terms of data types that can be stored. Let's understand the flexibility of types within a list using an example. Within a given list, you're allowed to store different types like string, boolean, integer, floating point, or even other lists. Here's an example list which is storing boolean values, an integer item, a string value, and another list. Let's go through basic examples using Jupyter Notebook session. I'll be addressing this bonus question as part of the basic example demo. Please pause the lecture video here and launch Jupyter Notebook session to follow along. Let me create a list L and I'm going to add the items as 1, 2.0, false, string high. Let's go through basic indexing examples for this particular list. I can say L of 0 to retrieve the integer value of 1. I could say L of -1 to retrieve the string value of high. I could say L of 2 to extract the boolean value of false. Len of L is going to be 4. That's because we have 4 items. Type of L is going to return a value as list. Let me show you one more example where we have lists within lists. I'm going to define my outer list as L. Within the outer list, my first item is going to be another list. So I'll have to type in another pair of square brackets. Within the first inner list, I'm going to define my items as 1 and 2. Let me add one more inner list within the outer list. Within the second inner list, I'm going to define the items as 3, 4, and 5 here. In Python, you can have any number of white spaces in between list items. You could also have a trailing comma. Python is going to treat this second inner list to contain 3 items even though there is a trailing comma. How can you access the inner lists here? You can simply say L of 0 to access the first inner list and L of 1 to access the second inner list. How can we retrieve the values within the inner list? Let's say that we want to extract the item 2 here. First of all, you'll have to say L of 0 to extract the first inner list, and then you'll have to say L of 0 of 1 to index into that particular inner list. So this is going to be a multi-dimensional indexing for your nested list here. Indexing is always applied left to right, meaning that Python will first index into the outer list L and retrieve the first inner list when you say L of 0. And then within the inner list, it's going to apply the second dimensional indexing, which is going to be of 1 here. This is slightly different when compared to function call, which are nested together. When function calls are nested together, the innermost function call will be the one that gets executed first, and then you'll move on to executing the outer function call. Unlike that, indexing is going to be executed left to right by applying the leftmost index first and then the right index next. How can you define empty items as part of a list? Can you simply say comma, comma, comma? You need to give none explicitly instead of just saying comma, comma, comma. Let me define a new list here. I'm going to say none as the first item, 1 as the second item, 2.0 as the third item, and none as the last item. When I say len of L, that's going to return the value as 4. Even though the individual items are none, the number of items within the list is still going to be 4. Why is this useful? That's because in real life, datasets have missing values, and you need a way to represent the missing values in a meaningful manner. None is going to come in handy for that. Let's go back to the previous example. Let's say that I want to flatten both of these lists together. How can I do that? I can use the concatenation operator for that. I can first of all retrieve the first list by saying L of 0. Then I can say plus L of 1, and that's going to create a flattened list which contains all of those items. So if I say len of this particular expression, that's going to return the value as 5 here. Let me switch to the slide deck, and I want to talk about the need for nested lists here. Recall that we initially motivated the list data structure by using the battleship problem where we want to keep track of a 10 cross 10 grid, correct? We can use a list of list data structure to represent such a grid. You can have outer list which contains 10 inner lists. Each of those lists represents rows. Then within the inner list, you can have 10 individual items, each of which will represent the value corresponding to a given column. That's going to enable you to keep track of all the possible user guesses using a single variable. The list of list data structure is very powerful. That's because a lot of data sets have a tabular format. So it's going to come in handy for you to bring the tabular data into a Python list of list data structure in order to be able to perform analysis on that particular data set. Let's talk about the concept of mutability. Mutability is a tricky concept, so please make sure to understand this clearly. A type is mutable if its values can be changed. A type is immutable if its values cannot be changed. The emphasis here is on the term values. Be very careful. Mutability has to do with values and it has nothing to do with variables. You can always change variables. What exactly do I mean by that? Let me give you concrete examples. Recall that I mentioned that list sequence is mutable, whereas string sequence is immutable. Let's consider this example of a variable update. I'm defining a list nums, which is going to contain the items as 1 and 2. I can simply redefine the variables nums to contain a different list which holds the items as 3 and 4. Similarly, I can define a variable s to initialize it with a string value of AB. I can simply reassign the variable s to a different string value of CD. I'm not really changing the value of the string AB when I say s equal to string CD. Rather, I'm creating a new string CD and changing the value inside the variable to the string CD. Similarly, when I say s plus equal to E, I'm going to concatenate the string CD with the string E, and that will create a brand new string CDE, and we are now going to reassign the variable s to that particular brand new string CDE. When you concatenate the string CD with the string E, you don't really change the value of the string CD here. So what do we mean by changing values? Let's go through examples for lists and strings. Let's say that you have a list nums which contains the items as 2 to 9. Let's say that we want to replace the third item 9 with a value of 0. I can simply do that by using indexing. I could say nums of 2, then I can say equal to the new value. This works for a list. That's because list is mutable. Similar example for a string would be to initialize a variable s with a string value of 2 to 9. I cannot say s of 2 equal to 0 to update a particular character within the string sequence. That's because string is immutable. One thing for you to notice with respect to list mutability is that you can only update existing index position value. For instance, I cannot say nums of 4 equal to 5 here. That will not work. That's because there is no predefined value for index position 4 within the list inside the variable nums. We are going to go through ways for mutating a list. Let me switch over to Jupyter Notebook and I'll be going through example for each of these modifications for a list. Observe that we have method calls as part of the list of ways to modify a list. So let me define a list as 229 here. I can simply retrieve the item in index 2 by saying L of 2. If I want to change that particular item, I can say L of 2 equal to 0. If I display L now, that's going to contain the items as 220. Can I say L of 4 equal to 5? That's going to throw an error. That's because the index position 4 is not defined for the list L. So how do you add a new item to a list? So you'll have to use a method call for that. The append method call enables you to add a new item to a list. So when I say L.append and pass argument as 5, observe that that's not returning any value. If I display L, that's going to now contain the items as 2, 2, 0 and 5. This is very different from string method calls. That's because string method calls do not update the string literal in the original variable. That's mainly because string is immutable. Unlike that, list is mutable. So list method calls are going to update the value inside the original variable, which is L here. How do you append multiple items? Can you just say L.append of list 1, 2? When we peek into the list, you'll see that that added a new list within the original list. So append is going to literally take whatever you pass as an argument and add that as an item to your original list. So could we say L.append of 3, 4? That's going to throw an error. That's because append takes exactly one argument. So how can you add two items to the original list, or for that matter multiple items? You'll have to use the extend method call. The L.extend method call is going to take a list as an argument. So I'm going to pass the items as 3 and 4 within the list L. Just like append, extend method call does not return a value. If we peek inside the variable L, you'll notice that the extend method call enabled us to add the items 3 and 4 directly into the original list items. So you're going to pass list as an argument for the extend method call. Let's talk about how to remove items. We'll be using the pop method call for that. Pop method call is going to return a value, so I'm going to capture that into a variable called RV. Pop method call is going to do two things. It's going to remove the item from the original list. So if we take a look at list L now, the item 4 is completely gone. And the second thing which the pop method call does is it will return the popped value from that particular method call as a return value. So RV is now going to contain a value 4 here. If you don't pass any argument to pop, that's always going to remove the last item from the list. If you pass an argument, then that's going to retrieve that particular item from that index position. Let's say that I want to retrieve the item from index position 4 and remove it from the list. I can do that by saying L.pop of 4, and if I display L now, the original list is only going to contain the items as 2, 2, 0, 5 and 3, and you would have removed the list 1 comma 2 from the original list. The last method call that I want to go through is for the sort method call. As the name suggests, the sort method call is going to rearrange the order of the items. Let me define a list here which contains a set of integer values. Let's say my values are going to be 3, 9, 2, 0, and 11. The sort method call, just like other method calls, is going to have an impact on the original list values. So you're going to sort the list items in ascending order. Let me show you a couple of other list examples here. Let's say that I have a list of strings which has values as hi, apple, orange. The sort method call is going to apply list sorting by comparing the individual strings using the string comparison that we learned in the previous lecture. So you're going to get apple first, high next, and orange last. Let's say that you have a list of Boolean values of false, and true. The sort method call is going to place the falses in front of the trues. Can you sort a list which contains multiple different data types? Let's say that I have integer, floating point value, and string along with a Boolean value. The sort method call is going to crash. That's because you cannot meaningfully compare an integer with a string or a Boolean value with a floating point value. On the other hand, you can have a list which contains just integers and floating point values. Python will be able to sort that particular list. That's because you can meaningfully compare integer values with floating point values. Observe that you're getting a sorted list for this particular example. Let me switch to the slide deck. I just want to mention that we'll be covering this particular demo problem as part of the next lecture. For now, we are going to skip over that. I'll wrap up this video here. In the next video, we'll be covering how to convert strings to a list of strings and list of strings to a string.